Want to ensure your app developers can create secure and smooth login experiences for your customers? With Curity, you can protect user identities, secure apps and websites, and manage API access. Find out more at curity.io.
Welcome to the What Have I Done podcast, where we ask ourselves, do we really want the technology future that we seem to be heading for? This podcast was inspired by that iconic moment at the end of the movie The Bridge on the River Kwai, where the British commander, Colonel Nicholson, realizes that his obsession with building a technologically superior bridge has aided the enemy, and asks himself, what have I done? Right before he dies falling on the detonator that blows up the bridge. For our first episode, I want to discuss the impact of large language models on software development. I have two guests, well known in the world of InfoQ, Anthony Alford and Roland Meertens. Both host a Generally AI podcast for InfoQ. Anthony is a director of development at Genesis, where he's working on several AI and ML projects related to customer experience. He has over 20 years of experience in designing and building scalable software. Anthony holds a PhD degree in electrical engineering with specialization in intelligent robotic software, and has worked on various problems in the areas of human-AI interaction and predictive analytics for SaaS business optimization. Roland is tech lead at Wave, a company which is building an embodied AI for self-driving cars. Besides robotics, he has worked on the safety for dating apps, transforming the exciting world of human love into the computer-readable data. I can't wait till that and LLMs get together. He also bakes a pretty good pizza. Welcome, both of you, to the podcast.
Thanks for having us.
Thank you very much.
I would like to start out with the assumption that we live at some future time, not probably too far in the future, when the problems of using LLMs for writing code have largely been ironed out. So the first question to ask both of you is, what does the software development lifecycle look like in this world?
Well, what I assume is that bots will automatically find issues within software. They can automatically raise a PR, and then other bots automatically accept the improvements. And basically, none of the code is readable anymore, which is not that much different than today.
That's a very cynical take. But then you've worked with robots a lot. So I start out with my general principle here is like, probably what will actually happen is going to be surprising to a lot of people. So I'm going to go with the safe bets, and I'm going to go with the concept of what robots are for, and therefore automating the tasks that people find dangerous, dirty, and dull. So I've never really experienced a lot of danger or dirt in my software development career, but there's a lot of dullness. So I'm going to go with the idea that the automation, the LLMs, are going to take care of the dull stuff. So like Roland said, maybe that's the definitely pull requests, right? Code reviews for sure. But also things like writing tests, writing documentation, things that we find hard, like naming variables. So the idea is to free up the time for the human engineers to focus on the important things like, do we use spaces or tabs?
In other words, coding standards.
Those are things which you should have ideally already automated, or like those decisions you should give to a linter normally, right? I think that's at least already something which you give away. I would like, who of you two is using GitHub Copilot at the moment?
I've used it for fun side projects. It's not bad.
But you're not using it for your day-to-day work.
So that's an interesting, one of the premises of this episode is that all of the problems have been ironed out. And one of the problems for us professionally at our company is we don't want to send data out into the potential training data set. And there's also concerns about the code that you get back. Who owns the copyright to that code, for example? So no, we're not using Copilot at work.
But it's because of legal trouble and not because of technical capabilities.
More or less, yes.
Well, both of you have hit on the idea that we're going to use this technology to do all the dull stuff and the easy stuff. So isn't that traditionally where novice programmers get trained? So the question then becomes, if we've automated all the easy stuff, how are we going to train programmers? What is the programming class of the future going to look like?
So the Copilot is actually, I think, a pretty useful paradigm, if we want to use that word.
Do you want to explain to some of the listeners what the Copilot is, because they may or may not know what it is?
Yeah, well, so it can mean a couple of things. The capital letter Copilot is a product from GitHub that is a code generating LLM. You type a comment that says, this function does whatever you want the function to do, and it will spit out the entire code for the function, maybe.
In whichever language you tell it to.
Right, exactly. Copilot could also mean an LLM that's assisting you. And I think might be a nice model for training novices. Maybe more like it's a real-time code reviewer, a real-time debugging assistant might even be better. The other way to look at it is maybe the LLMs save your senior programmers so much time that they'll have nothing else to do but mentor the younger ones. I don't know.
Well, this is, I think, what you're hitting on is one of the, I've always found the paradoxes of programming technology in general, is that unlike other engineering, for example, if you're a civil engineer, you can spend your entire life building the same bridge over and over again.
The big dig.
Well, yes. For those of you who don't live in Boston, that was a very interesting civil engineering experience for many years, paid for with taxpayer money from throughout the United States. But in any case, there were very few projects like that in the engineering world. We do something that has never been done before. When I was a graduate student, I took nuclear engineering, and on one of the final exams in reactor design we were supposed to design the cooling system for a nuclear reactor, not from physics first principles, but taking the ASME standard and applying that to the design. Software is very different. In software, if we want another copy of something, we just copy the bits. We tend in software always to do new things that we haven't done before, because otherwise, why write a software program? So the question is, how do you take an LLM or any technology that's trained on the past and apply it to a future that we don't necessarily know what it is?
But aren't you also frequently doing the same thing over and over again as humankind? Like that's why Stack Overflow is so popular, right? Because everyone seems to be solving the same problems every day.
Yes, but the question is, let's say, for example, I go back to the days, I don't want to say exactly how old I am, but I remember card readers, all right? And even before virtual memory. So yes, there are repetitive things, but people forget things like compilers, linkers, loaders, debuggers. These were all invented at some point in time, and they were new technologies that required insight, firewalls, load balancers. How does an LLM take all these things into consideration if it's never seen them before?
Yeah, but also I think that we started this discussion with how do you learn if you don't know about the past? In this case, I'm the youngest, being only 33 years old, and I unfortunately missed out on the days of punch card programming.
You didn't miss much.
But that's just what I'm asking is, how often do you in your daily work think, oh yeah, I remember this from the punch card days. This is exactly what I need.
But the point is, who would have thought of a compiler? In other words, an LLM is not going to come up with something new. Is it going to look at data and say, if we could do this, it would be great, and this is how we're going to do something that I've never seen before?
I'm mostly wondering what this means for future senior developers. So these are the people who are beginning with programming today. And I think the question is, are they going to learn faster because they can focus on code 100% of the time? instead of having to go through many obscure online fora to find the API call they need? Or are they not going to build a thorough understanding of code and what the machine actually does because they just ask ChatGPT to generate everything they do?
Yeah, I was going to say, yes, it's true that sometimes software developers have to solve a problem that has not come up before. But really, I think a more common use case is, it's like you were talking about with ASME standards. You're basically putting together pieces that you've already seen before, maybe in a novel way, but quite often not really. I need to make a REST API. I need something that stores, persists to it. I mean, this is how these frameworks like Rails and Django work. They know that there's common patterns that you're going to go to. I think that the LLM is just the next iteration of that.
So it's the next iteration: design patterns, architecture patterns, enterprise integration patterns.
Probably. The other thing is, I like I said, the code itself is not the entire job. There's a lot of other stuff. Let's take the DevOps model. At my company, the software engineers who write code are on call for that code in production. What if we could make an LLM be the first responder to the pager and have it either automate a remedy or, filter out noise or pass it along when it's stuck? LLMs could do other things like helping you design your APIs, helping you generate test cases, maybe even debug or optimize your code. I feel like, again, I talked about automating the parts that are dull, or maybe not necessarily dull, but maybe harder. I don't think we're going to see LLMs writing all the code. Maybe we will, but I think it's still very important. Like Roland said, we don't want code that's just completely LLM generated, because then nobody will know how it works.
Well, I think it's hard enough to sometimes figure out how the software we write manually works.
Exactly.
In fact, I've come across code that I wrote maybe 2 or 3 years ago and look at it and says, how does this work?
And so that's what
and incidentally, sometimes I try to convince myself there's a bug, but then I realize I was right the first time. And it's just that I forgot the intricacies of what was going on.
It is worse if there's a comment which says to do, fix this next to it.
And maybe that's the way that LLMs can help us. The LLM can explain the code to you, maybe. That would be a great start. Like,
yes.
What does this code do?
And I like your idea about the pager. Having worn a pager for a small period of time in my life, anything that would prevent me from getting beeped in the middle of something else would be a great improvement. So we haven't quite figured out how you train the new programmers yet, because I really want to come back to that. But how do you describe requirements? I mean, one of the things that's the toughest thing to do in a software development is figuring out what the requirements are. I've worked for myself for many, many years, and I've said over the years, there are only 3 things that I do in my life: inserting levels of interaction, trading off space and time, and trying to figure out what my customers really want.
So I actually made a note of that as well. If we could get an LLM to translate what the product managers write into something that we can actually implement, I think that would be a huge, because I've had to do that myself. The product managers, let's assume they know what the customers want, because they're supposed to. They know better than I do. But what they write, sometimes you have to go back and forth with them a couple of times. Well, what do you really mean? Like, how can I put this in more technical terms?
Well, I think the point is they very often don't understand the technology, and the customers don't. Because one of the things I find is, just because you can write a simple English language statement doesn't mean it's easy to implement. So that would be interesting. So how would you see that working with the LLM? In other words, the product manager says, I don't know, that we need something fast and responsive. How do you get the program manager, or the LLM would get the program manager to explain what they really mean by that?
But I think here there's 2 possible options again. On the one hand, I think that sometimes thinking about a problem when manually programming gives you some insights And that also goes for junior developers who need to learn how to code. It's often not the results which counts, but the process. It's not about auto-generating a guitar song. It's about slowly learning and understanding your instrument. On the other hand, if you have a product manager which asks for a specific website, if you can have ChatGPT generate you 5 examples, and they can pinpoint and say, yes, that's what I want. If you can auto-generate mockups or auto-generate some ideas, then maybe you get it right from the first time instead of first having to spend 3 sprints building the wrong product.
So an LLM is another idea is to have an advanced prototyping tool.
Absolutely. I think we've all seen that demo where somebody drew a picture on a napkin of a website,
Yes,
and they
right.
give it to the image understander.
Interesting. So I think because there's been a lot of attempts to do prototyping, code generation. I'm sure you've all seen them in the past. And there's a sort of frustration with them, but maybe large language models can, again, how would you train such a prototype? Would you put before them samples and because one of the things I think with machine learning in general, they don't understand vagueness very well. In other words, you give machine learning algorithm something, it comes up with an answer, but it doesn't come up with probabilities. And when you're doing prototyping, you're combining probabilities, and there's no certainty. So how do you solve that kind of problem? If you understand what I'm trying to get at.
But isn't this the same problem as we used to have with search engines, where people would go to a search engine and they would type, please give me a great recipe for a cake. And now everybody knows to type chocolate cake recipe 15 minutes or something.
Right, because we train the humans to deal with the software. But ideally, it really should be the software that can deal with the humans.
But I think my father already stopped using search engines and is now only asking ChatGPT for answers, which I don't know how I feel about that.
I asked ChatGPT to come up with a bio of myself, and it came up with something that was 80% true, 20% complete fabrication, but I couldn't tell. Yeah, I knew because I knew my own bio, but reading it, you couldn't tell what was true and what was false.
But are you paying for GPT-4?
This was on GPT-3, I think I was doing this.
Yeah, I noticed that on GPT-3, it also knew my name. I assume that it knows all of our names because of InfoQ. Right. And then it generated something which indeed was 80% true and 20% made me look better than I actually am. So I was happy with that. And GPT-4 actually seems to do some retrieval.
Isn't that a game, 2 truths and a lie or something like that?
Yes, it is. But isn't that the worry about using large language models in general?
Yes, but I would submit that, we already have that problem, right? Developers have been writing bugs for, ever since, I guess, even Ada Lovelace maybe wrote a bug. Right, I don't know. Right.
Well, that was supposedly the term bug came because Grace Hopper found an insect in the hardware. But I think the saving grace I like to think with software developers, unlike the general public, they could recognize when the LLM has generated something that makes no sense. Either gets caught in a test case. In other words, you could have maybe one LLM generates the test cases and another one generates the code, sort of the way they like to have battling sometimes machine learning systems.
Yeah, and maybe that's the way we'll wind up doing this is invert it. The human is the code reviewer, although I can't imagine that would I hope it's not to that point. Nobody likes reading code.
Oh, no. Yes. And to do a code, I've done code reviews because, again, being in this business for a long time, that was a big thing. Code reviews at some point in time, people said that was going to solve the software quality problem. And to do a code review is really hard.
Yeah.
Because you have to understand the assumptions of the code. You have to spend time reading it. So I would hope that the LLMs could do the code reviews.
Me too.
But I mostly want to make sure that we keep things balanced, not that the product manager automatically generates the requirements and then someone automatically generates the code and then the reviewer at the end has to spot that the requirements were bad to begin with.
Well, you see, you raise an interesting point here, because when we speak of requirements right now, even when you talk about the program manager, the project manager having requirements, that's already with the requirements is some way fleshed out. But if you've ever done real requirements analysis, and I have, you sit down with a client and they don't really know what they want. And you have to pull that out of them. And there is a art form of asking open-ended questions. Because most of us ask, we do requirements analysis, ask them, do you want A or do you want B? But you already narrowed the field and given the person you're asking perhaps a false choice. You have to be able to deal with open-ended questions. And you see LLMs being able to deal with open-ended questions and then refine down as answers come.
I really like the idea of the LLM as a rapid prototyper and even a simulator. I've seen projects where people have an LLM pretend to be an API, for example. I have a feeling that would be quite handy.
And in that case, you'd still be training the software developers the old way. Yeah. Let's go with that idea for the moment. So the LLMs are the rapid prototypers. They may or may not generate reusable code, because one thing I found with prototypes is you have to be prepared to throw the whole thing away. Because you very often get in trouble when you build a prototype and then you say, I want to salvage this code. You have to be prepared to throw the whole thing away. So we use the LLM to come up with a rapid prototype. So then what's the next step? I mean, and also I'm thinking, when I think of the next step, how do you do the utilities? The security, the scalability, because it's one thing to design an algorithm. It's another thing to design an algorithm that can scale.
Yeah, well, the security part, for example, our company, our security team is already doing a lot of automated stuff. I think that's another great fit for an LLM. Maybe not an LLM, but automation for sure is something that security people use a lot. Maybe LLMs are good on like reading things like logs to find intrusion, for example. So anyway, that's the only part of that I have an answer for. I don't know about scalability other than maybe helping you generate load at scale somehow. Roland, you got an idea?
No, not really. In this case, I must also say that as a human, I don't always know how to do things except for go to InfoQ and see how other people do, like how other experts do things. I can only imagine that an LLM has already read all of the articles you guys wrote, so they can already summarize them for me.
Assuming I was right to begin with in the article.
Yes. Yeah, but in that sense, I think that those code generation and like requirement setting could be a good way to brainstorm. And I think that's something like ChatGPT can remind you to also think about the entities.
So what I hear being developed is that the LLMs are essentially being used as idea generators. Maybe. Checkers to make sure that the human has done. Have you considered this? I've looked at the code, and yes, it may generate a lot of stupid things just looking at the code, but it will generate a checklist. If you use this API, have you considered this? If you, should you use a mutex here or, something like that? Is that sort of where we're going with this?
Well, as this podcast is about what have I done? Like, I think the dystopian thing I'm not looking forward to is that I think there will be a day where someone adds me, like a junior developer will add me to a pull request. I argue that I am right and their AI generated code is wrong. And then I probably learned that their ChatGPT generated code was better to begin with, and their AI generated proposals faster than my code.
But so that's humiliating for us, but that's not necessarily a bad future. So going with that idea, what could go wrong? Let's say we were doing a pre-mortem. You're familiar with the idea of a pre-mortem. Something is successful and you ask yourself, well, what could go wrong? What could go wrong here?
I think we've already kind of touched on it. I think a big risk of having generated code like this is when something goes wrong, nobody has an idea how to solve it. So here's something that I have this idea with autonomous vehicles. And some of you who are experts in that area may fact check me here, but my suspicion is that if all vehicles were autonomous, overall traffic accidents would go down. But the ones that happened would be just absurd. Like it would be stuff that no human would ever do, like on The Office, driving into the lake or something.
Right.
I suspect something similar would happen with generated code.
I think let's take your analogy, because I think there's something very interesting about this. Before you get to I think the day with self-driving cars, the problem is the world getting to self-driving cars. When you have humans and self-driving cars at the same time, you have a problem. I'll give you two examples. One is there's something called the Pittsburgh left, which for those of us who drive the United States, you generally, if you're at an intersection, the cars going straight have the right of way over the cars that are turning. But in Pittsburgh, there's a local custom that those making the left turn have the right of way. So the question is, you have a car that was trained on data in some other city that comes to Pittsburgh. What is that situation? Or you have the situation that happened in Sweden, where they went from driving on the left side of the road to the right side of the road overnight. Humans did wonderfully. I don't see how a self-driving car could do that.
I'm are only hearing that we need to learn from situations as fast as possible, and that we need end-to-end learned driving. So you actually capture all the nuances in all the different areas.
But also I think the easy case is when everything is automated. And as you say, Anthony, there is that case where it comes across something it didn't expect, like, a chicken running across the road. But if everything's automated, then everything's predictable because they all know what they should do. The problem is in the world where you're half automated and you're half not, that's where you get into a problem. And I don't know if there's an analogy here with you brought up self-driving cars, analogy with doing the LLMs to generate code and not knowing, if the LLMs are always generating the code.
But I still think that the problem is mostly here with humans, that thinking about the code and thinking about the problem gives you insights into what you actually want to achieve. Whereas if you automate everything, like at the end, you maybe have a website very quickly, but why did you make this website again? Or were you just happy that ChatGPT generated it? Or I think that's at least one thing which I noticed when using things like ChatGPT is that at the start I use it quite often to help me write a message to a friend. I'm like, I don't want to lose the capability of writing messages to a friend. I think we all lost the capability of remembering 10-digit phone numbers because we just store them in our phone.
Well, I still can do that, but that's because I got trained at that a long time ago.
Yeah, and the younger folks, they don't know how to remember 10-digit numbers anymore.
Well, it always amazes me at the checkout, when I sometimes check out, and I sometimes like to use cash instead of a credit card. And I can compute the change in my head, and the person at the other, how'd you do that?
Yeah. Yeah, so maybe at some point someone will say, wait, you can actually open Notepad and edit the HTML yourself.
Well, that's Back to the Future.
Yeah.
We're going to turn this into the kids today.
Actually, you raise a very interesting point there, because let's go back to the point, you're talking about, you were both talking about figuring out what ChatGPT has done. The question is, how elegant will the code? Because if ChatGPT can clever, you could have the equivalent of go-tos all over the place. They could produce spaghetti code and they understand it. But then if you have to do what you say, open up Notepad and look at the HTML, you look at it and say, what the hell is going on here? And is that a danger?
Have you guys seen that DeepMind's Alpha Dev found a faster sorting algorithm?
No.
Yeah, I did see that headline.
Yeah, a while ago, they trained some kind of reinforcement learning agent to generate code, and their algorithm found I think they went from, 33 instructions to 32 or something like that. So it was a bit faster than the fastest human written code.
But the question is, in sorting algorithms, because I go back to the good old days where you had to choose them and write them yourself. Sorting algorithms are not universally used in all cases. For example, bubble sort, if I remember going back to, is a very good sort, except if the data is almost already in ordered state. Do I recall that right? Or I don't know. It's whether. So the question is, how do you, when you situation we just had where you came up with a faster sort, does the algorithm now know the cases to use this sort? Or is it just going to blindly use it every place?
Or maybe you can apply this algorithm to your specific deployment and you just tell it, optimize my P99 latency. And then you don't know what's going on, what kind of A/B tests is set up. But your P99 latency slowly goes down. You don't know if that's maybe because your AI starts rejecting customers from a certain country. I think that's the real danger, is what are you optimizing at the end of the day?
So what you're saying is that in this world of LLMs, we have to log almost a lot of stuff.
Yeah, well, actually, now that I started thinking about it, if the LLM is going to be part of your software development pipeline, we're going to want to check in the prompts into Git. You're going to want to commit your prompts to the source code because now that's the source code.
Right.
Maybe.
So then you have version control on the prompts and you have, well, the question is then, all right. So let me think about this for a moment, because many, many years ago, I worked in the computer design world for military, and the military is one of the users of the application. And they used to, when they archived the designs, they archived the software that was used to create the design. So if they ever had to revise the design, they could bring back the exact software to use it. So are you suggesting perhaps not only do we archive the prompts, but we archive the LLM that was used with those prompts as well?
I think you should. It's almost like pip freezing your requirements for Python environment. I don't know. It depends on the model we're using, right? If the LLM is just a co-pilot and it's helping you, I mean, that's basically the same as copy and pasting from Stack Overflow.
Right. Because you have the responsibility in the end for what you cut and paste in or what you put in or what was generated. So the question then becomes, at some point, does the LLM become like compilers who we just assume it works? I mean, I can remember one time actually finding a bug in a compiler because it put an instruction on a page boundary and we took a page fault. It actually caused it. But that's really sophisticated. And you have to understand what's going on behind the scenes. So are people going to understand?
I think you can build up this understanding faster. So I personally, people are probably going to laugh, but I have no clue how to write SQL queries or work with other like large databases. So I don't really know how to work with, PySpark. But nowadays, all these tools have AI built in. So the only thing I do is say, fetch me this data from this table and then do this with it and select these specific things. And the first day that you're doing this, you have no clue what you're doing, but you get some auto-generated code, which does the thing for you. And that's great. But then after a couple of weeks, you start seeing patterns and you actually start learning it. So it's more interactive learning for me and slowly learning an API through AI generated commands. And whenever something crashes, you can actually ask it to fix it, which is insanely powerful.
But you said something very interesting. So one of the things you do learn when you've done SQL, and believe me, I've written my share of SQL in my life, is that, for example, if you're doing certain types of queries, you may want to put indices on columns.
Hints.
Or hints, or you may want to renormalize or denormalize things, for example, for performance. There are all kinds of things that you may not learn or the thing may not know to do. So again, I guess what I'm trying to get at is there's always some sort of contextual or meta problem. So what I'm afraid of is in this new world where LLMs do a lot, that people lose their knowledge of the meta problems. Like they lose their ability to make change. They lose their ability to have long attention spans or whatever it is. And they lose the context and they begin to trust these things. And then we find ourselves in a situation where it's too late to get out of, except to rip the whole thing up.
I don't know if we'll get to that point, but I do think that, as someone with teenage children, I can kind of see the other side, right? There's a reason we're not still writing machine code, most of us.
Yes.
Some of us do, very few of us, I imagine, but, I'm sure that when the compilers came along, everybody was saying, "God, these kids today don't know how to write machine code."
Yeah, they did. They did say it. They did say that. But they don't know how to write assembly.
But we do kind of I still learned it. And it wasn't that long ago, I hope. But anyway, where I was going was I like what Roland said. If we can use these things as tools to help us learn things, help increase our productivity, I think that is a good future. I think, sure, we'll lose a few skills, but sometimes, really in the grand scheme of things, is writing machine code a skill that people still need?
No, probably.
People still can write.
Well,
writing's been around a long time.
I know that when phones first came out, the ability to write, machine language code was very important. That skill had to come back because you didn't have virtual memory. You had to worry about memory mapping and things like that because this goes back to the whole context.
Yeah, my wife was still writing assembler in the 21st century for embedded software.
Yes,
for sure.
So again, this comes back to, I guess, the point of context and knowing where the tool works and where the tool doesn't work. And I'm afraid that would get lost in such a world where people don't know what, I guess, as Donald Rumsfeld said, it's the unknown unknowns that get you, or the limits of the tools that get you. And the more you automate, the more you run the risk of that. So where's the happy medium? Because again, economic efficiency is going to drive us. The most expensive thing in a programming project probably is the cost of the programmer.
Yeah, or alternatively, the highest cost is the very large SQL query this developer wrote who had no clue how to use indices.
Right.
I would say that's R&D cost. What's the cost of an outage, a multi-hour, multi-day outage of your software? It's true that there are always going to be companies that are foolishly short-sighted in some ways, but the ones that survive, we hope, are the ones who are not.
But the question of what is the path for them getting them to survive? I mean, how much suffering is there in the process of that evolution? I mean, dinosaurs disappeared in the process of evolution. They didn't make it, but that took a long time. And so the question then becomes, how do we know what we don't know? Because I think the economic efficiency, I'm convinced, because I've seen this happen over and over again, Most managers think programmers are irreplaceable, interchangeable, especially if you get to larger organizations.
Fungible.
Okay. So that is going to provide an economic incentive for people to get rid of programmers and to use technologies. I mean, I remember years ago, before even LLMs came out, people were saying, automatic generation of code is around the corner.
Yeah, they've been saying that for a while.
Yes, but there was a strong incentive for managers to believe this. Because programmers are pains in the neck. They cost money. They say no. So get rid of them. I'm playing devil's advocate here to some extent, but that is going to be a big push, I think, for having LLMs or startups that can't afford programmers.
But then you will lose a lot of the tribal knowledge in companies.
Yes, you do. But are they going to care? The more I think about this, the more I realize this world that we move to is a world that, a lot of technology changes. Like, for example, take phones. No one thought about the attention span problem. No one thought of TikTok. No one thought of, spyware. No one thought of all the privacy problems.
I agree that in that sense, the difference between a good senior developer and a bad senior developer, I think, will be how much restraint they were able to use to either automatically accept every LLM-generated proposal or taking a minute to think through what is actually generated.
Mm-hmm.
Although reading is going to become a way more important skill. Reading code and quickly being able to understand what's happening and either accepting or rejecting it.
Well, I think you're right. One of the things that I learned very early in my programming career is that code is read far more often than it's written. And code should be written from the point of view of the reader, the potential reader, as opposed to the writer. In other words, Donald Knuth, I'm sure you both know that name, wrote a book called Literate Programming. His idea was you program in an explanatory way.
Yeah, but how often do you take a moment to read some nice code? I always think it's kind of weird that if you are a science fiction writer and people ask you, what is the last book you read? If you say, I never read books, people will be like, how can you be a good writer? But if you ask programmers, what's the last code you read? People are like, I'm not going to read code for fun. Even though that's the new skill to have.
I used to read code all the time because I had to debug other people's code. Look at code. I read code so that I could understand my peers. I learned from reading code from my betters when I got started. So perhaps that's a skill that's going to have to come back in the future world. So I'd like to sort of just sum up at this point and ask both of you. The question is, based on our conversation, any thoughts you have, what does this world look like? And do we really, really want to live in this world? Because now's the time to say stop. Now, can we really say stop? Is it like the atomic bomb that's going to be developed by somebody and then everybody has to have it? Or is there a realistic chance that we can say that this is not a good idea? Or it should be restricted to a certain area?
I was going to say, if anybody could stop it, it would be the lawyers, but I don't know if they will.
Well, they're already starting. Well, for example, did you know the story about the Air Canada bot?
Yep.
I know the story about the Air Canada bot. Yeah, it promised things it couldn't promise. And,
yes. But the thing is that Air Canada tried to say, no, this is a platform. We're not responsible. And the judge said, no, you're responsible. So most of them, I think, are copyright lawsuits right now. But eventually there will be lawsuits. So that's one thing. That's certainly a possibility.
So if I were going to say, here's how we could turn this future into a bright future, I'd say let the machines write the code, but let's write really good tests. And that's what I tell my development teams today already. Let's make sure we have really good tests. And if we have really good tests, if we run tests all the time, we run tests for scale, for security, and all that, fantastic. We'll keep an old timer around who can go in and debug the code or, look at the code and make the tweaks. But other than that, let's let her rip.
So what happens when the old timer retires? How do you get the next old timer?
There's always somebody who's an old timer at heart.
So what you're suggesting, if I understand you correctly, is a division of labor.
Yeah.
That also means that the LLMs have to learn to write testable code.
Well, that's the key. And
Yeah.
that's all of us.
Yes, but that's the point. In other words, for your division of labor to work, the LLM has to generate code that can be unit tests, that could be scenario tests, that can be use case tests. It has to know how to do that.
The way we do testing is we use our API. So we write tests that call our API. So end-to-end tested, unit tests for sure. But of course, end-to-end tests, that's the truth.
But you also have to test the user interface as well.
Right. That's a great human skill.
Yes.
I think for me, I would, as someone who has been using Copilot for ever since it was in beta phase, I learned a lot of new tricks in terms of programming from having this Copilot automatically inject code into my code. And I have therefore explored APIs, which I would normally never do, like found new tricks which can do things faster. And if I would have to think about them from scratch, I would have not implemented them this way. So I became a better programmer with the help of LLMs. But people should show restraint. Don't just accept every suggestion.
Right.
Keep thinking about what you actually want to achieve. And I think this constraint for me is the hardest. So sometimes when I get tired, I notice myself accepting everything which gets proposed. And that's the moment where I start writing extremely bad code, very bad prototypes. Nothing makes sense anymore. It's not maintainable anymore. So you have to be at least a certain amount of awake to use it responsibly. It's like a lot of things which are addictive. You gotta keep using it responsibly.
So I have two more questions before we wrap up. One is, again, how do you train the new developers? You talk about exercising restraint. You're coming from a world where you wrote code and you know what restraint is. How do you teach the next generation of programmers to fear, to respect, whatever adjective or verb you want to use, to know how to treat the technology?
You keep pressing the needs work button on GitHub until they finally get it right.
Anthony?
Yeah, one of those, maybe I don't have the answer. I should have the answer. I think it's experience.
Mm-hmm.
We could copy and paste code from Stack Overflow. How do we know whether we should or not? Some of it's experience. And I think with the younger generation, sometimes you throw them in the deep end.
Yes.
Of course you mentor them, right? You don't let them drown, but
they come close to drowning.
But that's how people learn, is by making mistakes. And so we got to give people an environment where they can make mistakes. It's just like now, we got to give people an environment where they can make mistakes, where a mistake is not catastrophic. And I was going to say, cross our fingers.
Well, yes, there's always a certain amount of crossing our fingers with software development. Just to ask you the last question, to think about, Colonel Nicholson, what would cause you to say, what have I done with this technology? What is it that you would fear or cause you to ask yourself, what have we done with this world?
I think for me, there are a lot of things which used to be fun for me because there was a certain challenge to it, from generating simple websites about something silly or building cool tech prototypes about something cool. a lot of those things which would previously would be a fun weekend project, you can nowadays generate with ChatGPT in 5 minutes, and that takes all the fun out of it. So as long as I can keep doing things manually, I am extremely happy. But just knowing that something can be automated sometimes takes the fun out of it, unfortunately.
I think just losing sight of the fact that we need to stay in control. We need to exercise restraint. We need to not let the robots take over. I think that's the fear we all have. I think, when it comes down to it, that's the fear we all have, is that the robots take over. I don't think that's going to end life, but it could be very expensive for a company if, something bad happened. So that's where I would see, what have I done? You're, as a CTO, say I'm not a CTO, but if I were a CTO and we implemented this and it ruined the company, oops.
Well, thank you very much, both of you. I found this very interesting, and hopefully our listeners will learn something, and hopefully we'll have a chance to make the world a little bit better place, get people to think about stuff.
Yeah, it was a lot of fun. Yeah, thanks for having me.
Thanks for having us.